Okay, so today's example, it's another one that used to be in the book that they took out. It is a valve cap. Now, the difference between this drawing and the ones you've seen previously are that we actually have dimensions on here. We're no longer trying to figure out what side goes where. We're actually looking at actual dimensions on the drawing. The valve cap is literally a valve cap, just like on your tire, except this one has a lip that goes around it and a complete pass-through hole. One thing to notice, people assume that it is symmetrical from side to side. It is not. If you read the dimensions, it is asymmetrical. One side is larger than the other. So let's begin. What is the total length of the workpiece? It's simply right here is 0.170. You can see that these two, what type of lines are these? Extension lines goes from the one end of the workpiece to the other end of the workpiece. And the dimension line at the top tells us it is 0.170. All right. From what material is a part made from? For that information, where would we go?
Material.
We would go to the material block in the title block, and it says right here, 316 SST, which is stainless. Very good. All right, the next question. How deep is the .178 diameter counterbore measured from the outer face of the valve cap? So this requires a couple of different things here. First of all, you have to know what a counterbore is. The counterbore is measured here on the sides. Okay? Counterbores have 90-degree angle corners on them, as opposed to this, which is either a countersink or a chamfer. This is a 90-degree countersink. Now, we need to know what the 1.78 diameter counterbore is. So to find the 1.78 diameter counterbore, I look here, the symbol for diameter, the circle through the line with it. 0.178 is the top, 0.176 is the bottom. And we follow our leader lines and we see that it goes to this piece right here. Now the question asks, well, how deep is it from the face of the object? The face of the object is out here. And right here we have a nice reference. It says it's 0.095 or 95 thousandths from here to here. All right. Now, number 4, what is the high limit of the large outside diameter? The large outside diameter is measured from here to here. So our answer for the high limit is 0.345. All right. Now, it asks for how long is the 15-degree chamfer. Now, we don't know if this is a chamfer or a countersink until it is marked. Usually countersinks are either 90 or 100 degrees, not 15 degrees, so that's a pretty good indication there. But then we have to measure the length of the chamfer. As you can see, it is marked right here. It's 0.025. Notice the arrows are on the outside and not the inside. That's perfectly acceptable. The arrows do not have, the dimension does not have to be between the two parts being measured. The next question, what is the scale of the print? We go back to the title block, and it is 5:1, which means that 5 inches on the drawing equal 1 inch in the actual part. So this is a very small part. The next question, what is the smallest size a large hole can be machined? Okay, well first let's determine what the large hole is. We have 3 holes. The largest is the 0.178 to 0.176 diameter hole. And so the largest the hole can be is a 0.176. That means at 0.176 that hole is at the most material condition. We'll talk about that later, but the smaller the hole is the most material it can have, and the larger the hole, the least material we can have, which is opposite from a measurement. All right. Number 9, what is the smallest radius allowed on the part? Where would we find that?
0.093.
It is actually 0.005.
In the notes.
It is in the notes. So if we look over here in the notes, it says, if I get it in the picture, right here in the notes, maximum radius or chamfer is 5 degrees. All right. Next question. What is the maximum allowed size of the smallest hole? So the smallest hole, remember we have 3 holes, is listed here. It's 0.095, and the smallest, and the maximum size would be 0.095 for the least material condition. Right. Now, how thick is the right flange of the part? This one's tricky. We only have one view, so it's very hard to determine what the right side flange is going to be, isn't it? So, remember, when we turn our object up, it's a rounded object, so that's going to be difficult. We will turn down, and then we will turn to the left. Therefore, the right side flange would be here, and so in this case, our right side flange is the top. So our answer is 0.028 to 0.032. That's a very tricky question. Remember, you got to turn it down and then over. So this right side will become, the top becomes the right side. Back to the title block again. What is the tolerance for angles? Plus or minus 1/2 degree. All right, number 13. How deep is the 0.150 diameter counterbore? We find that again by looking here, 0.150, measured from the face of the 0.178 counterbore. So we want to know how deep is this counterbore measured from here. Oh, sorry. He's going to tell me if I'm off the screen. So this one's a little bit trickier. You are going to be 0.038 to 0.042, which would be from the back side of this that's listed right here. Also acceptable for this answer could be 0.112 to 0.108 if we measured from the outside face. It does not specify. So once again, your answers are 0.038 to 0.042, which is listed right here. The second answer, which requires you to add dimensions together, would be 0.112 to 0.108. We get that by adding this dimension to the depth of this counterbore to get the 0.112 to 0.108. All right. What is the size? What size is the small hole? We've already had one question about that. It's right here. It's 0.093 to 0.095. How long is the 45 degree chamfer? Find the 45 degree chamfer. It's here. And the length of the 45 degree chamfer is measured right here, from here to here. So from here to here, 0.022 to 0.018. How many radii are on this part? Now you have to be careful here. Some of them are marked. We have one here. We have, notice, 2 here because this arrow goes to 2 different radiuses. And the arrow goes to 2 here. This is a round part. So if we have 5 radii, what would our total radii be? That's correct, 10. There are 10 total because even though they're not marked, they still exist on the other side. How long is a 0.095 diameter hole? Once again, this hole. This time we want to know the length of this hole. And the answer is 0.037 to 0.033. It is right here. Okay. Next question. What is the part number? So once again, where are we going to go? To the title block. Customer part number VC-000513. Next question is, what do triangles symbolize? If you look on the notes, you'll see that there's a note for the triangle. It says critical dimensions for SPC. And the last question, does the part go to the finishing department? It does not. Box is blank.